one, we're going to find the Maclaurin series for f of x equals x cosine of x. We're also going to find the associated radius of convergence with the ratio test. So basically, to save some time here, we want to write this in the Maclaurin series definition given here, and then write it as a sum here, or here. So let's go ahead and look at some derivatives. So if I just look at the first one, I'm going to do f of 0 and write down my function x cosine of x. And we're going to evaluate this at x equals 0. Now, when you evaluate 0 here, that's just going to equal 0. So I'll put that there. All right, now when n is 1, that's your first derivative of f with the 0. So this is going to be negative x sine of x plus cosine of x. Now when you evaluate that at x equals 0, you're going to get 1. Because this the sine of x is going to go away. Now let's try n equals 2. So we take the second derivative, and that's going to give me negative x cosine of x plus 2 sine of x. Evaluating that at x equals 0, that's going to give me 0. All right. 3. F triple prime of 0 gives you x sine of x minus 3 cosine of x. When you evaluate that at x equals 0, that's going to give you negative 3. All right, let's see. Let's do 4. So that's the fourth derivative with 0. That's going to give you x cosine of x plus 4 sine of x. Now at x equals 0, that's just going to give you 0. We're going to have to do a few more because this is not repeating yet. We want to get it where it's going to repeat. So if we do 5, we go to f, the fifth derivative of 0, and it's not going to really repeat. It's just going to alternate. You can start seeing a little bit what's going to happen. Let's do a few more. So at 5, we're going to get negative x sine of x plus 5 cosine of x at x equals 0. That gives me 5. I'll try to squeeze in one more here. So let's try to squeeze in the sixth one. Well, the sixth one, if I do 6, that's going to be f, the sixth derivative with 0. That's going to equal negative x cosine of x minus 6 sine of x. And evaluating that at x equals 0, we're going to get 0. So to save some space here, let's look at, let's see, if I do the seventh one, so if I do f to the seventh derivative, it's going to be negative 7. So what we're going to get is, when you look at these numbers here, it's going to be negative 7, 0, and then we're going to have 9, 0, and then the next one would be negative 11. So do you see where we're going by odd numbers here? So looking at that, we can write out our series using this definition here. So let's do that. We're going to have x cosine of x equals 0 plus 1x plus 0 minus 3 x cubed, and this is divided by 3 factorial, plus 0 plus 5 divided by 5 factorial times x to the 5th plus 0 minus 7 divided by 7 factorial times x to the power of 7 plus dot dot dot. And what ends up happening is you're going to get x minus 1 divided by 2 factorial x cubed, then plus 1 divided by 4 factorial times x to the 5th power minus 1 divided by 6 factorial times x to the 7th. And that's because we have this number up here. So this is going to go down 1. So you've got 5 divided by 5 factorial. So that's why that happens. If you want to delete that 5. All right. Now plus dot dot dot. So putting this in this form here, we're going to have the sum n equals 0 to infinity. We have alternating signs, and then it's going to be 1 divided by, and this is going by even numbers, so that's 2n factorial, and then for our power here, we're going by odd numbers. So that's going to be to the power of 2n plus 1. So this is your answer here. All right, now let's go ahead and find the radius of convergence. We're going to use the limit test. So we're going to take the limit as n approaches infinity of absolute value of a sub n plus 1 divided by a sub n. And we're going to use what we had. If you want, I'll write it again. So we had n equals 0 to infinity, negative 1 to the power of n, 1 divided by 2n factorial times x to the power of 2n plus 1. All right, so for our numerator, we're going to get the limit as n approaches infinity, and we're adding n plus 1. So it's going to be absolute value of negative 1, and now we have that n, so it's going to be n plus 1 times x. When you add the next term here, it's going to be 2n plus 3. On these, you just add that 2 to the 1. And then the denominator is just going to be 2n plus 2 factorial. Again, you're just doing 2n plus 1 everywhere there's n. So you'd have to distribute that. Now, for the a sub n, we're supposed to divide. It's the same as multiplying by the reciprocal. So we're just going to put the denominator up here, 2n factorial. And then for our denominator, we're going to have negative 1 to the power of n times x to the power of 2n plus 1. All right, now we're left with simplifying all this. So with the limit as n approaches infinity. So let's look at this. For this part here, this is just going to equal negative 1. But when you take the absolute value of that, that just equals 1. So this is just going to cancel out. Now let's look at our x's. For our x's, we're going to have x to the power of 2n plus 3 minus 2n minus 1, using your properties of exponents. So that's just going to give you x squared. And we can go ahead and take off this limit thing. So, I mean the absolute value. So we have x squared. Now, let's look at the denominator. Looking at these two. So, looking at this is really 2n plus 2 times 2n plus 1. Keep subtracting 1. Then you're going to have 2n. You can keep going, but we want to stop and write this as 2n factorial, because that way these two cancel out. So now we're just left with this. So the denominator is going to be 2n plus 2 times 2n plus 1. Now evaluating that limit, that is 0, which is less than 1, using the ratio test. So for all x, our r is infinity. Thank you. Have a nice day. Bye bye.